go again. Today we are going to be talking about graphing radical functions. Just see how excited you all are. Oh my god, graphing radical functions. Now, for some reason my eyes are going crazy, so I might be rubbing them a few times. It's not because I'm tired, never tired. It is, it's 7 o'clock in the morning. It's like practically noon. So, anyway, graphing radical functions. Hopefully, at this stage in your life, you know what the square root of 9 is. Maybe you even know what the square root of 1 is. Maybe I can't figure out how to move this thing. There we go. All right, here we go. You can take the square root of lots of different numbers. But when you're working with the radical functions, what we call the toolkit functions, just the regular old square root of x right here. Oh, I should highlight it in yellow. Regular old square root function. Remember, f of x stands for y, is the same as y, not stands for, but it's the same as a y value. So we're looking for the y values. So, I mean, I can grab my graphing calculator, but I don't really think I need to. You know, if I plug in a 0 on a square root function, I'm going to get 0. Can I plug in any negatives? Well, at this point, you already know that you can take the square root of a negative number, and you know that it equals negative, you know, if the square root of negative 1 is just I, but you're not going to be able to plot on the real coordinate system on imaginary numbers. It's just not going to work. So you're going to have to plot real numbers. Well, let's just plot the ones we know. We know what the square root of 0 is. It's 0. If I take an x value of 1 right here, my y value is the square root of 1, which is just 1. Now, I could do 2. I could do 3. But I don't know what those square roots are. So I'm not going to do those. I'm going to, that's that 2 right there. That's 3 right there. Here's 4. The square root of 4 is 2. Square root of 9 is 3. Square root of 16, way out here, it's 4. I don't care because I don't need to worry about it. I'm just going to plot this graph. Now, the regular graph function of a square root, the regular f of x equals the square root, this toolkit function, it looks like this. Now we're just going to play around with it a little bit. Let's go over here to the left side. What have we added? We've added this negative right here in the front. You see it? I'm pointing at it right now. If you can't see it, open your eyes. It's right there, negative. We know that when we put a negative in front, I don't care whether or not it is a linear function, a quadratic, a cubic, whatever it is, it's going to just take the thing and reflect it in whatever that, in this case, it's going to reflect it in the x-axis. So if I plug in 0, I still get 0. If I plug in 1, I'm going to get the square root of 1, which is 1, but the negative in front makes a negative 1. And I think you can see where we're going with this. There's 2, there's 3, there's 4, and I'll take the square root of 4, and it's 2, but we put the negative in front. The square root of 9 is 3. And we put the negative in front. And you should be able to look at both of these two functions that I have so accurately drawn. Kind of hard to draw with this thing. That they're just reflections in the x-axis. That's all they are. And then we're done with those. This is going to be a short video, hopefully. All right, so we've talked a lot about the fact that when you have adding or subtracting next to the x value. When we did it with absolute value bars, it was within the absolute value bars. When we did it with parabola, it was in the parentheses squared when we had it in vertex form. I still don't know why I said that twice. But here we have here it is, the x value, or we are changing this thing. We are translating this thing somewhere. We're going to make some type of transformation on this. Well, in this case, since I'm just subtracting 3, but I'm doing so inside, that's going to shift it either left or right. It's going to be a horizontal shift, left or right. And if you remember correctly, when we add 3, what that does is or when we subtract 3, that's going to move it to the right 3. 1, 2, 3. It's going to move the entire thing. So normally my vertex would be here. But because I added 3, I'm going to slide it over here, and now my vertex is over here. All right. Now, I talk a lot about, okay, when we're doing the absolute value, we want to move away from this vertex. Wherever we've slid this starting point, in this case, I'm not sure if you want to call this a vertex, but wherever we slid this sliding point, we want to move 1 away from it. Well, if I move 1 away from it and I take the square root of 1, I get 1. Well, that's really the value is 4. When I plug 4 in, 4 minus 1 is 1. That's why it's 1. Then I want to move 4 away from it. Well, 1, 2, 3, 4 puts me right here. And the square root of 4 is 2. But I'm really at 7. I'm really at an x value of 7. 7 minus 3 is 4. And the square root of that is 2. So I've moved this over to, and I've drawn it in. Alright, now what have we done here? Well, in this case we've moved it to the right 3 and we've moved it up 4. So again, we'll go back to the fact that normally my vertex is right here. I'm going to try to get through this pen. I think my pen might be dying. Here, we're going to go to the right 3 and up 4. So here's my starting point. Now, I'm going to go from there, because square root functions, I just want to use perfect squares. So I'm going to go from there, right 1 and up 1. Well, what have I really plugged in? I've really plugged in the value 4. 4 minus 3 is 1. Square root of 1 is 1. 1 plus 4 is 5. And that's why it's the 0.45. Then I'm going to move 4 away. 1, 2, 3, 4, and I'll go up 2. Again, I'm just using perfect squares. And I'm trying to hit those points. Really, I am. I'm having issues with my pen. I'm not sure what they are. Oh, and I think we didn't talk about range. Let's talk about range here, and domain. In this particular case, my domain value is, because we started at positive 3, my domain values are 3, comma, infinity, parenthesis. But that's my domain values. My range values, because I'm still starting at the x-axis, my range values actually haven't changed. My range values are going to start at 0. Notice I'm using a bracket because I can equal that. That looks terrible. I don't know. Hopefully, this isn't a long video, so hopefully I'll get through this, manage to get through this one. Over here, my lowest x value is right here somewhere, right here, and that's 3 again. So again, I'm going to start at 3. I'm going to go off to infinity. But my range value has changed. It's actually moved up. It's moved up to positive 4. So the lowest y value is positive 4, and we're going up to positive infinity. Oops, and I got to put a parenthesis there. But having a hard time with this pen. All right. So the only thing I've done here is I have not done any translations. I've not moved it left. I've not moved it right. I've not moved it up. I've not moved it down. The only thing I've done is I've added this 2 in front. Well, this 2 in front is a dilation. It just stretches the graph. It's either going to stretch it bigger and faster, or it's going to stretch it down and go up smaller. In this case, because it's a 2, it's going to stretch it to go up a little bit faster. So when I plug a 1 in, and the square root of 1 is still 1, but I got to multiply it by 2. So instead of going up 1, I'm going to go up 2. When I plug a 4 in, 1, 2, 3, 4, and I go up, I'm not going to go up 2. I'm going to go up twice that, 4. And when I plug a 9 in, I'm not going to go up 3. I'm going to go up twice that, which is 6. So you'll notice if you compare this one, let me see if I can draw this one. If I compare this one to this one up here, it just goes up steeper. And I think you guys should get a handle on what's going on over here. In this case, we just got a -2, which just means it's a reflection in the x-axis. So we're just coming down. So we're going to go to the right 1 and down 2. We're going to go to the right 4 and down 4. We're going twice as much, not 2 this time. And we're going to go to the right 9 and down 6. Twice as much. Now the range values here are actually the same as the range values in the first one. The domain, starts at 0 and goes to positive infinity. Range, same thing, starts at 0, goes to positive infinity. Now here over here, let's take a look at this. The domain is the same. It's not changing. It's still going to the right, starting at 0, going all the way to positive infinity. But in this case, the range is starting at 0, but it's going down to negative infinity. And lots of kids are going to write this. Starts here at 0 and goes down to negative infinity. But you can't write this as domain. Let me just erase that and pretend I did not even see it. Can't do that. Remember, when you're dealing with range values or when you're doing an interval notation, the smallest number has to go on the left. So in this case, the negative infinity. What is the lowest number on the graph? The smallest number going down. In this case, it's going to be negative infinity all the way up to and including 0. All right, we're done with that one. Now we're doing cube roots. Well, what are my perfect cubes? Let me write these over here somewhere. We've got 1's a perfect cube. Well, 0 is. 0 times 0 times 0. It's kind of boring. 1 is 1 times 1 times 1. The next one will be 8. 2 times 2 times 2. The next one will be 27. 3 times 3 times 3. 64. 4 times 4 times 4. 125. I'm only going to ever get these probably on a graph. I'll never get 27 on a graph. It's just not going to happen. So let's see what happens. Oh, but I can take the square root, or in this case, the cube root of negative numbers. We'll start with 0. Again, I'm going to go up perfect cubes to the right 1 and up 1. The cube root of 1 is 1. Now, the next number that I actually know the perfect cube of is 8. So I'm actually going to go way out here to 8 and go up 2. So that's the right side of the perfect cube function. But because I can take the cube root of negative numbers, I also have to go to the left. So I come out here to negative 1. The cube root of negative 1 is, in fact, negative 1. The cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. And I can draw going, hopefully I can draw going to the left. Okay, that's it. Now, on the next one, I've done 2 things. By the way, the range for both of these is negative infinity to positive infinity and negative infinity to positive infinity. The range on this one, start at 0. We're going to move. We're not moving. We have no translation. We have no vertical movement up and down. We have no horizontal movement left to right. We do have a dilation, so it's going to go up faster instead of going up kind of shallow like this one over here does. It's going to go up much steeper. We also have a reflection. So what we're going to do is we're going to put in 1. And if I plug in the cube root of 1, it's still 1, but I'm going to multiply by negative 3. So notice I'm going to be coming down. Now the next one is negative 8, or positive 8. The cube root of positive 8 is 2. 2 times 3 is 6. So I've got to come down here to 6. And notice it's reflected in the x-axis, so it's coming down to the right, not up. But it's also doing it at a much faster pace. Then we're going to type in negative 1. The cube root of negative 1 is negative 1. Negative 1 times negative 3 is actually positive 3. I'm going to come out here to negative 8. The cube root of negative 8 is negative 2. Negative 2 times negative 3 is positive 6. It's up here somewhere. And we're just going to draw this in. And usually I try to hit the points, but doing so in this case. Now, does that change the domain and range? Absolutely not. The domain and range here is still negative infinity to positive infinity. Negative infinity to positive infinity. So again, we've talked about these. This is a dilation. It's just going to make it go up steeper or shallower. Dilation. This will be a shift. If it's negative, it shifts it to the right. And that's backwards from what you might think. If it's positive, it shifts it to the left. This number on the outside is a vertical shift. If it's positive, it's going to go up. And if it's negative, it's going to go down. Nothing changes over here. Nothing changes. A, it's a dilation. Now, if it's negative, and I haven't talked about that here, but if it's negative, we also have a reflection. So instead of it going its regular direction, it's going to flip upside down. Again, this will be a shift left or right. Left if it's negative. Excuse me. Left if it's positive. I want to make sure I wrote it right. And right if it's negative. Again, this is backwards from what you might think. You know, if I want to go to the right, that's a negative. If I want to go to the left, I'm adding in there. And again, this is the same as before. Positive, you're going up. Negative, you're going down. So let's go through a few translations on some of these things, and then I think we'll be done. We'll state the domain and range. And I'm not doing the inverse. I don't know why I put this in here. So we're going to get rid of this. We don't have to do this. So again, normally my vertex would start here. Or my starting point right here. This is a square root function. So I'm going to use the square root numbers that I can on a graph. It's going to be 1, 4, 9, maybe 16 if that's possible. I'm not sure if that's possible. Nothing bigger than 16 would work. Next one's 25. This graph only goes 10 to the left and 10 to the right, so no way I could use 25. So, let's see. I'm going to go, let's see, subtract 1, that means to the right 1, and add 2, up 2. So that's actually my starting point. This thing down here would have been my starting point, but I don't need that anymore. All right, so I want to go to the right 1 and up, not 1, but up 2, because I also have a dilation in this one. I'm going to go to the right 4 and not up 2, but up 4, because again, I have a dilation in this one. And I'm going to go to the right 9, which takes me all the way over here to 10, and up 6. Normally the square root of 9 is 3, but because of that dilation in the front, I have a 2. I have to go up 6. So my domain is from 1 to positive infinity, and my range is from positive 2 to positive infinity. That's it. Done. Next one's a cube root. So the cube numbers I want to use are going to be 1, 8, and then 27, but can't use 27. So normally I would be here at the beginning of the origin, but I'm not. I'm moving to the left 8, way out here. But I also moved down 3. So there's my actual starting point. Because I moved to the left 8 and down 3. Let me get rid of that point, because that point doesn't exist. So from here, if I go to the right 1, that's the cube root of 1. Now this is really negative 7, isn't it? If I move from negative 8 to negative 7. Negative 7 plus 8 is 1. Cube root of 1 is 1. 1 minus 3 is negative 2. Right here. The next number I want to use is 8. So that means it takes me all the way over here. 8 away. Well, that's really an x value of 0. And if I plug in 0 into this function, 0 plus 8 is 8. The cube root of 8 is 2. 2 minus 3 is negative 1. Now, I'm not going to get 27 in here. So that's pretty much all I'm going to be able to grab. And I'll just do that. And then, again, if I go to the left 1, it's just going to come out and go like that. And again, you could use the graphing calculator to see this. Oh, domain and range. Domain and range for this one are all reals. There's no restrictions on domain. Cube roots won't have restrictions on the domain because you can take the cube root of negative numbers. Square roots, on the other hand, are going to have them. So, negative 2. We're going to move to the left 2, down 5. There's my new starting point. I'm going to go to the right 1, up 1. We're going to go to the right 4, up 2. We're going to go to the right 8. Or 9. That's 4, 5, 6, 7, 8, 9. Is that 9? Yeah, that's 9. Well, that'd be 10. 9 is here. Up 3. And I can't go to the left because you cannot take the square root of negative numbers. So I can't put in negative 3. Because if I put in negative 3 here, I would have a negative number. So you can't put in negative 3. So there's your starting point. Those are the only 3 points I can graph. I'm not worried about the inverse. The domain is from negative 2. We move to the left 2 to positive infinity. And the range is from, let's see, we went down 5, so negative 5, and we're going all the way up to positive infinity. All right, this one has a reflection. Again, it's a square root function, so I'm going to be only using square roots. So I move positive 2, that's left 2, positive 6, up 6. And it's right here. Now, normally I'd move to the right 1. There's no dilation, but there is a reflection. So normally I'd move to the right 1 and up 1, but I'm going to move the right 1 in, down 1, because we have that reflection. I'm going to move to the right 4 and down 2. And I'm going to move to the right 9 and down 3. Now, because it's a square root, I don't have to go to the left. I can't go to the left because that would be involved imaginary numbers. We're not graphing those on this set of axes. All right, that's all she wrote for that. I think we have one left. There it is, last one. So this is a cube root. I'm going to be using 1/8. No way I'm getting 27 on there. We're going to shift it. We also have because of the negative, we have a reflection. So let's see. We're going to move to the right 2 and up 6. 1, 2, 3, 4, 5, 6. Now, I normally go to the right 1 and up 1, but because it's negative, I'm going down 1. There is no dilation, so it's still down 1. Then I would go to the right 8, which takes me way over here to 10, and the cube root of that is... I just screwed this up. I apologize. I want to start over. I just messed it up. You know what? I was just checking my work, and I said 10 plus 2. That's 12. I can't take the cube root of 12. And then I realized, wait a second. This is a plus 2 and plus 2. So you can get caught up in these things. Sometimes you're just like, oh, plus 2, go right 2. Don't do that. Plus 2 means it's a shift left 2. I apologize for that. A little brain cramp. Not enough coffee in me this morning. That's my excuse. I'm sticking with it. We're going to go to the right 1 and down 1. We're going to go to the right 4 and down 2. Same as before. But this came, again, we got the negative. We got the negative in front, which means it's a reflection. And then I'm going to go to the right 8, which takes me out here to 6 and down 3. The reason it's 6 is because 6 plus 2 is 8, and the cube root of 8 is 2. But because of that negative, it's really negative 2. Oh, and I go up on it. 1, 2, 3, 4, 5, 6. Now, anybody see it? Made a mistake. Let me show you what I did. Let me show you what I did. And I'm just trying to demonstrate here that there's common mistakes that you can make. You get caught up in doing some crazy stuff without using your brain. All right, so the first mistake, which was quite honestly an honest mistake, but then I decided let me throw in a few others in here, or at least one other. Let's see if I throw another one in later. I'm not sure if I'm going to. I plugged in a 4 because that's a perfect square. But I'm not working with perfect squares. So I shouldn't be using perfect squares. I should be using only cubes. And then when I got to plugging in a 6, 6 plus 2 is 8. The cube root of 8 is 2. The negative out front makes it negative 2. But then negative 2 plus 6 is 4. And I hit 3. So then you're like, all right, wait a second. What's going on here? So evaluate what you're doing, making sure. Again, I would use the calculator. I can't bring that up today. I'm having issues with my calculator. So we're going to go to the right 8, which is really here and down to here. And I'm done, right? What do you think? Am I done? No, it's a cube root. In cube roots, you can go to the left and the right. So if I go to the left 1, I'll go up 1. And if I go to the left 8, I'll go up 2. So that is what this one should look like. And again, this one is a cube root. And the domain on perfect cubes is all reals. Well, it looks like there's another page. Doesn't look like there's another page. Somehow I'm missing a page. Oh, no, I'm not. This is number 11. Okay. I already did this page. Ah, cool. 12, 11. They went out of order. How the heck did I get this to be number 12 and that to be number 11? And this is number 11 and this is number 10. What in the world did I do here? I got the numbering so messed up. That's why I messed up here. 9, 10, 11, 12, 11. All right. That last one should have been 13. We're done. Peace out. Finished. That was an easy one. Take it easy, guys.